Hello and welcome to this solution video. If you like this video, please give it a thumbs up, share this with your friends and subscribe to Math United. Let's start with question number 1. Solve this equation. Let me write it properly. It is 8 to the power 3 minus 6x equal to 4 times 5 to the power minus 2x. You have to solve the equation, means you have to find the value of x correct to 3 decimal places. So let's use logarithm for solving this one. I'm using natural log. You can use the other log also, normal base 10 log, but I'm using natural log. It doesn't matter, it will give you the same answer. So what I'm going to do here is that I'm going to apply natural log to both sides. When we apply both sides, it applies to whole of the sides. Okay, so when we have this natural log, the exponent will become the coefficient. So it will become 3 minus 6x as coefficient, then natural log, and only 8 is left. Similarly here, since two parts are multiplying, they will add up. So it will become natural log of 4 plus natural log of 5 to the power minus 2x. Then this exponent also will become the coefficient just like this. So I'm going to expand this and put this minus 2x in front of natural log. So it will become 3 natural log 8 minus 6x natural log 8. The purpose is to isolate x. The right side is natural log 4 minus 2x natural log 5. So these two parts have x, they will come together. So let me bring it here. So it will become 2x natural log 5x positive minus 6x natural log 8 is equal to natural log 4, which is already here, and this minus 3 natural log 8 will come as a negative. So now this is x, which we will take as common, and we will be left with 2 natural log 5 minus 6 natural log of 8, and then we have ln 4 minus ln 512. Okay, let's write this one same because calculator has to do its work, so we don't have to bother. Okay, so x will be, this whole thing is multiplying with x, so it will become the denominator to the right side now. 2 natural log 5 minus 6 natural log 8, and then we already have natural log 4 minus 3 natural log 8. Just put this in a calculator and you will solve the equation, and what I'm getting here is 0.5241033, and there are some more digits which we will round off to 0.524, 3 significant figures. Question 2. Find the exact coordinates of the coordinates, okay, stationary point of the curve, this one. Okay, so what we'll do for stationary point, dy over dx has to be equal to 0, because whenever there's a stationary point, maximum or minimum, the gradient of this tangent is always 0, and dy over dx is nothing but the gradient of the tangent. So we will have our equation first. Y is equal to e to the power 2x sine 2x, and then we'll differentiate it with product rule. Why? Because there are two parts which contain the variable x are multiplying. So first we will keep e to the power 2x as it is, but we will differentiate sine 2x, plus we will keep e to the power 2x as differentiated, but sine 2x will be untouched. Okay, the differentiation of sine 2x is 2 cos 2x. So we will write 2 as coefficient, e to the power 2x and cos 2x. Then we will differentiate this. The differentiation of e to the power 2x is, e to the power 2x remains what it is, multiplied by the differentiation of the power, which is 2 sine 2x, and both of them have 2 to the power e to the power 2x and cos 2x plus sine 2x, and that has to be equal to 0 by this rule, because we have to find stationary point. Okay, so either 2 e to the power 2x is equal to 0, or cos 2x, doesn't matter, but let's write the way it is, cos 2x plus sine 2x equal to 0. E is a constant, 2 is a constant, they can never be 0 no matter what power you give to them, so there is no answer from here. Here we will write sine 2x here, but cos 2x can go to the other side, or now yes, minus cos 2x here. Now we'll divide both sides by cos 2x, so that this cancels out, and here we get tan 2x equal to negative, nothing is left here, they cancelled out, so minus 1. 2x is tan inverse minus 1. Now we have to find where the tan is negative 1. So we know negative tan is in this quadrant, and this quadrant it is negative, and tan inverse 1, negative has decided the quadrants. Now we'll do tan inverse 1 in our calculator, which gives us pi by 4, and that pi by 4 will be nothing but the angle with the horizontal line in both the quadrants we decided. Okay, but our calculation, our answer will start from this 0 degrees, so this will be our first answer from here to this line, which is pi by 4 less than pi. So our first answer of this one is that 2x is equal to pi minus pi by 4. And second answer will be 2x minus equal to this is 2 pi also, and we are pi by 4 lesser. If we start from 0 and reach here, we will not reach 2 pi, we will reach pi by 4 lesser, so it will be 2 pi minus 1 over 4 pi. So 2x is equal to how much? 4 minus 1, 3 pi by 4, and x gives us 3 pi by 8, and our domain is from 0 to pi by 2. 3 pi by 8 is less than pi by 2 and more than 0, that's correct, so this is our answer, x equal to 3 pi by 8. What about this one? 2x is equal to 8 minus 1, 7 pi by 4, and x gives us 7 pi by 8, and 7 pi by 8 is more than pi by 2, so this answer is also ignored. There is only one stationary point, and that's what they're saying, stationary point, not points, but they said coordinates. So we know x, we can find y by substituting in this equation. Let's find y also. Y equal to e to the power 2 times 3 pi by 8 multiplied by sine 2 times 3 pi by 8, 3 pi by 4. Okay, and in this quadrant 3 by 4 is here, sine is positive, which is 1 over square root 2 or square root 2 over 2, let's say square root 2 over 2, and here 2 and 8 cancel, so we'll get e to the power 3 pi by 4 times square root 2 over 2, and if you want you can write square root 2 over 2 first, and they said exact coordinates, so this will be the y coordinate. So our exact coordinate will be, what was x? X was 3 pi by 8 and square root 2 over 2 e to power 3 pi by 4. Question 3. The square roots of 24 minus 7i can be expressed in Cartesian form. This one, where x and y are real and exact, by first forming a quartic equation in x or y. Find the equation square roots of this in the exact Cartesian form. Okay, so they're saying that square root of 24 minus 7i is x plus iy. Okay, let's square both sides. So this square and square root gets cancelled, so we are left with 24 minus 7i is equal to, if I expand this, it will be x square. I will use the same identity we use many a times. A plus b whole square is a square plus b square plus 2ab, right? So a square plus b square, which will be I square y square plus 2ab. Okay, so 24 minus 7i is equal to x square minus y square. Why? Because I square is minus 1, it becomes minus y square, plus I, let's write 2xyi. Let's write this way. Okay, so now this is the imaginary part, this is also the imaginary part. Equate imaginary parts. So minus 7 is equal to 2xy. Okay, I'm ignoring the I part because both have i's. So let's isolate this x. So this 2 and y will become the denominator of minus 7. This is our relationship between x and y. Okay, now what would I do? I will equate the real parts now. So then we will write equate real parts. The real part in this one is 24. Here we have x square minus y square, the real part. And from here we'll substitute x. So 24 equal to negative 7 over 2y square minus y square. So what are we left with? Let's expand this. 24 equal to 49 over 4 y square minus y square. Let's get rid of this denominator by multiplying the whole equation by 4y square, so that we get rid of the denominator. So 4y square times 24 will be 96 y square, yeah, equal to 49 remains 49 because 4 y square and 4y square will cancel out, and minus 4y to the power 4. And now we got what they wanted. Let's bring this to the left side. It becomes positive 4y to the power 4 plus 96 y square minus 49 equal to 0. This is the quartic equation they wanted. The quartic equation, this is the one. Now we have to find x and y so that we can give answer in exact Cartesian form. So we have to find the solution of this. For this, let's assume y square is equal to t to make it a quadratic equation. So what does our equation become now? 4t square plus 96t minus 49 equal to 0. Okay, so We can split the middle term in this, or we can use the quadratic formula. Let me use quadratic formula. So t will be equal to minus b plus minus b square minus 4ac over 2a. Just put this carefully in your calculator and you will get two answers. Let me use my own calculator. By the time I do this, I would request you to like this video, give it a thumbs up, share with your friends, and subscribe to Math United. So what I'm getting here is t is equal to exactly 2, or t is equal to minus 98. T was not t, it was y square originally, so let's go back to y square, which is 2. So y is square root 2. Here y square will be equal to negative 98. So y will be square root negative 98, which is not real, because they've clearly said in a question that where x and y are real and exact. So this cannot be an answer because it is not real. So this is our y. What about x? X is this one, which is minus 7 over 2 y. Y is square root. By the way, it is not square root 2 only, it is plus and minus square root 2. When you square root them, plus and minus both. So it will be plus and minus both 1 by 1. So 1x is this, and second one will be minus 7 over 2 times minus square root 2, and nothing gets cancelled, but we have to rationalize the denominator. So it comes out to minus 7 square root 2 over 4. This will be 7, positive 7, yeah, 7 over 7 square root 2 over 4 by the same rationalizing method. So the square roots, find the square roots of 24 minus 7y. So the square roots are, x is minus 7 square root 2 over 4 and y is positive square root 2. So I square root 2. This is 1, and the second one will be positive 7 square root 2 over 4 minus I square root 2. These are the two square roots in Cartesian form. Question 4. The variables x and y satisfy this equation where k and c are constants. The graph of natural log y against x is passing through these 2 points with a straight line as shown in the diagram. Find the values of k and c. Give each value correct to 2 significant figures. Okay, so since this is forming a straight line, but our y-axis is not y, we will write a different equation for a straight line, which is capital Y is equal to m capital X plus c. Whenever we have such a case, when we have abnormal axis, we just use different kind of x and y, but we keep a touch with the normal equation of a line. So if this is the matter, what will be the equation of this line? It will be y equal to m. M is gradient, right? Gradient is y2 minus y1 over x2 minus x1. Yeah, that is the gradient, m. And that's what I'm going to do here. In place of m, I will write y2 2.21 minus 0.372 over x2, which is 5.1 minus 2.8, which comes out to be 0.799 some digits, so we will round it off to 0.8. So we have to write x and plus c. X is capital X in this case. So now we want to find c in this equation. Let's substitute one of these 2 points, and let me substitute this point here. So y is 0.372 in this case, equal to 0.8, and x for this point is 2.8 plus c. So c stays here, and this 0.8 times 2.8 will go to the other side. So it will be 0.372 minus 0.8 times 2.8. If I use my calculator for this, I get minus 1.868. Now you can see that the y-intercept doesn't look like to be minus 1.868, but this is not drawn to the scale because this y is very, very small. This point should have been very, very close to 0 here. So that's why it is not to the scale. So it will, if it was the case, it would go something like this and reach somewhere here. So don't worry about that. Now we'll write the proper equation, final equation after this. So y is equal to 0.8x minus 1.868. Now our original y-axis was natural log y, so we'll replace it by natural log y now, and the capital X will be replaced by simple x because it is just x here, minus 1.868. So if I remove natural log from this side, it will become y equal to e to the power 0.8x minus 1.868. Since the power of e are subtracting, we can also write this as y equal to e to the power 0.8x divided by e to the power 1.868, right? And now we want this format. Ky is equal to e to the power cx. E to the power cx, we got it. This if I multiply, I'll get k. So e to the power 1.868y is equal to e to the power 0.8x, and e to the power 1.868, we can put this in a calculator and get our value for that. By the time I do this with my calculator, I would request you to like this video by giving it a thumbs up, share this video with your friends, and subscribe to Math United. So what I'm getting here is 6.475332 more dots y equal to e to the power 0.8x. Now this will give each value k and c correct to two significant figures. So k is this one, which is how many? Two significant figures, 6.5, and cx, okay, it will be 0.80. Question 5. Express this in partial fractions. Straightforward, nothing, no big deal. The only big deal is that the degree of denominator is 2 and degree of numerator is also 2. So we can't straight away start our process. We have to divide first. So first let's convert x minus 1, 2x plus 1, the denominator. Let's expand this so that we can divide. So we will have what? 2x square, x multiplied by 2x, then x multiplied with 1 is x, minus 1 multiplied with 2x, and minus 1 multiplied with plus 1, minus 1. So it comes out to be 2x square minus x minus 1. And we will carry out the long division now. So 2x square minus x minus 1 becomes divisor, and our dividend is the numerator, 6x square minus 2x plus 2. So we will need 3 to make 2x square as 6x square, but it will not only multiply with 2x square, it will multiply here also, minus 3x it will give us, and minus 3 this will give us. Now if we subtract with the signs change, this becomes minus, this becomes plus, this becomes plus. So this cancels out, and here we get just x minus 2x plus 3x, and then 2 plus 3 is 5. So now 3 is our quotient which we'll keep aside, and this becomes our new numerator. This is what we have to express in partial fraction, x plus 5 divided by x minus 1 and 2x plus 1, and we have to assume this as a divided by x minus 1, so that we separate the two denominators we are multiplying, and 2x plus 1 here. So the LCM will become x minus 1 to x plus 1. To equate them, x plus 5 numerator of this side, and what will be the numerator of the right side? A will multiply with this, 2x plus 1, and b will multiply with x minus 1. Now we will assume that x is equal to 1, so that 1 minus 1 becomes 0, this part. So we'll assume x is equal to 1, and what changes happen here? It will be 1 plus 5 equal to a 2 times 1 is 2 plus 1. So this becomes 0, so we will not go to the b side, so it will become 6 equal to 3a. So a comes out to be 6 divided by 3, which is 2. For b, we'll assume that x is minus half, so that this becomes minus 1. Minus 1 plus 1 will be 0. So let x equal to minus half. So minus half plus 5. Equal to, this becomes 0. So we'll be going to b straight away, b, and minus half minus 1. Okay, so 5 minus half will be 4.5, so which is 9 over 2 positive. Okay, equal to minus, this will be minus 3 over 2 b. So both have same denominator, we can cancel out, so b becomes minus 9 over 3, which is minus 3. So finally our partial fraction, which we assumed to be this, becomes a was 2, positive 2, so 2 divided by x minus 1, and then we have minus 3 divided by 2x plus 1, and we had this quotient already, we can write that separately, plus 3. This becomes our partial fraction. Question 6. A part. On an Argand diagram, shade the region whose points represent complex number z, which satisfy both the inequalities this and this. Since these inequalities are a little complex, we can make them simple by giving them a reference point. So let me change this one first. The first one, which is the modulus. So I can change it to z minus 4 plus 3i less than equal to 2. So what I've done, I have written z, which is the complex number they're talking about. With reference to 4 plus 3i, its modulus is less than 2. Okay, so let me draw the Argand diagram first. So this is my real and this is imaginary axis. Okay, I want 4 plus 3i. Real is 4, imaginary is 3. So if I say 1, 2, 3 and 4. This is the real. 1, 2 and 3. This is imaginary. So this is the point from where the modulus will be less than 2. That means if I draw a circle, its radius will be less than 2. So let me try to draw a circle like that, and so it will be reaching at 1 here, and 3 is here. So 3 plus 2, 5 will be the maximum, and it is not reaching at 2. So let me make it a little wider from this side. Okay, now this is the center, the one I've drawn here. This is the center, which is 4 plus 3i, 4 on real, 3 on imaginary, and the radius of this particular circle is 2, and the shaded part is this white part. So this is done. Second, argument, this time not the modulus, argument is z minus 2 plus I. Again, I have separated the z from the remaining part, and it has to be more than or equal to 1 over 3 pi. So our reference is 2 plus I now. The real is 2, which is here, and imaginary is 1. From here we draw a half line, which will be this way, and the angle from this half line will be pi by 3. So let's see, it is in this direction. This angle is pi by 3. And it has to be more than 1 over 3 pi. That means it has to be more than this, but both the inequalities must be satisfied, so we can't cross this circle. So this is the shaded part now. This is the region they were asking us to shade. Okay, and then this is what they wanted us to do. Okay, let's move on to the next part, which is calculate the greatest value of argument z. So argument, and there is nothing with z, that means z minus 0. So 0 is the reference point from where the z will have the greatest value. So from this 0, if I draw a line, the greatest will be here, which seems to be parallel to this yellow line, but doesn't look like properly parallel, and it is the greatest angle anywhere on this region. Let me show you the points. This region, in this region, this is the only place where it is giving us the greatest angle here, this argument. Okay, so this is the angle, let's call it alpha angle, we have to find out. Okay, and we have to calculate. So let's do what? Let's connect this with the center of the circle first and find part of this alpha. Let's call this beta, this small angle. This small angle beta is the argument of, let me write it properly. Beta is argument of 4 plus 3i. Yeah, because this is the point where this line is reaching. So this beta angle will be the argument of 4 plus 3i, which will be tan inverse 3 over 4. Yeah, 3 opposite over adjacent 3 over 4. So we got beta. Let's get the remaining part, this one, which is, let's call it gamma. So our alpha is beta plus gamma. What about gamma? Gamma will be, let's join this line here. So it will become a triangle. Let me redraw that triangle now. So this is 90 degree because this line is a tangent to the circle. So this angle has to be 90 degree. This radius is 2. We know the radius of the circle is 2. And this is 5, which is this line is 5. Well, how? Because that is the modulus of z. 4 minus. So how did I get this 5? Let me show you. The modulus of 4 plus 3i has to be square root 4 square plus 3 square, which is 5. So I know this is 5, this is 2. So gamma, this angle, will be sine inverse opposite over hypotenuse. So 2 over 5. And since alpha is beta plus gamma, we'll just add tan inverse 3 over 4 plus sine inverse 2 over 5. So alpha, which is argument z greatest, equal to alpha, which is equal to tan inverse 3 over 4 plus sine inverse 2 over 5. And we can find the answer with our calculators. By the time I do this, I would request you to like this video, give it a thumbs up, share the video with your friends, and subscribe to Math United. What I'm getting here is 1.055. So let me say 1.06 radians. Fx be this 8x cubed plus 54x squared minus 17x minus 21. Show that x plus 7 is a factor of fx. For being factor, if x plus 7 is a factor, so if x plus 7 is equal to 0, if the factor is 0, if I multiply it with anything it will become fx, will also be equal to 0. Yeah? Okay, so what I'll do, this gives me x equal to minus 7. So if I substitute x equal to minus 7 according to the remainder theorem into this function, I should get a 0. So what I'll do, I'll write 8 minus 7 to the power cube plus 54 minus 7 square minus 17 times minus 21. Sorry for this delay. It should be equal to 0. So let's see. 8 times minus 343, this will be, and this will be plus 54 times 49, and that will be 17 times 7, 119. Positive, because both are negative. This is negative, this is negative. It will give me 119 minus 21. Let's put this in our calculator and we should certainly get 0. Once we do this, they're asking us to find the quotient if this function is divided by x plus 7, this polynomial rather. So x plus 7 is our divisor. It divides 8x cubed plus 54x square, then minus 17x minus 21. So let's divide this like we did one of the previous questions. So to make x as 8x cube, I have to multiply by 8x square. So that it becomes 8x cube. And 7 multiplied with 8x square will give me 56x square. So if I change their signs, this will cancel out, and this will be minus 2x square. I'll bring down one more, minus 17x, because there are just two of them, so there is no need to bring the third one right now. So to make x as minus 2x square, I'll multiply it with minus 2x. So minus 2x times x is minus 2x square. And x times 7 times minus 2x will be minus 14x. And I change the signs again. So this cancels out, and this will be minus 17 plus 14 minus 3x. And now I'll bring the last one, minus 21 here. So I need to multiply x with minus 3 so that it becomes minus 3x. So minus 3x. And when minus 3 multiplied with 7, we get minus 21. Obviously, the denominator will be, not denominator, the remainder will be 0. According to remainder theorem, we already got it earlier. And that's why this is the quotient they were asking for. Now, hence solve the equation, and it is exactly same equation. You can see 8x cube, 8 cos cube theta, 54x cos square, 54x square. So it is exactly same. In place of x, we रुक जाओ थोड़ी देर. In place of x is being replaced by cos theta, right? So that means we have to factorize this whole thing. X plus 7 is already with us as one factor. We have to factorize this also. So let me do it here. 8x square minus 2x minus 3. I have to factorize this, and I will split the middle term. 8 times 3 is 24. So what are the two factors of 24? So that we get a difference of 2, it is 6 and 4. Yeah, but I want minus 2. That means 6 has to be negative. So that minus 6 plus 4 will be minus 2. So that's what I'll do here now. 8x square minus 6x plus 4x minus 3. So I have splitted the middle term into two parts so that I can factor the first two. The GCF for these, the GCF of these two is 2x. So if 2x is divided out of this, we'll be left with 4x. And minus 3 will be left out of this. There is nothing common in here, so we'll take just plus 1 as common, and it will be 4x minus 3, and that solves our purpose because both are 4x minus 3. We can take 4x minus 3 as common from both. But I'm left with 2x and plus 1. And we had x plus 7 already. So these are three factors of the original function. And this equation is in terms of cos. So now we will proceed with cos. So it becomes 4 cos theta. In place of x, we have cos theta now. So 4 cos theta minus 3. Then we have 2x. So 2 cos theta plus 1. And then we have cos theta plus 7. And their multiplication is 0. So multiplication of different parts is equal to 0 only if one of them is 0, right? So we don't know which one is 0, so we'll equate every one equal to 0, every condition, so that it gives us some solution. So 4 cos theta minus 3 is equal to 0. This is our first solution. This will give us first solution. Next will be 2 cos theta plus 1 equal to 0. And the third one gives us cos theta plus 7 equal to 0. So let's rule out this one, because cos theta can never be minus 7. Cos theta is always between 1 and minus 1, right? But this is giving us a situation where cos theta is minus 7. So this is rejected. We don't get any solution from this. Let's go to the first one. Theta is equal to cos inverse (3 over 4). Okay, so cos is positive. So if we look at our quadrants, cos is positive where? In first quadrant and the fourth quadrant, right? So this angle will be cos inverse 3 over 4. And if I use my calculator, I'll get an angle which I will write at these two acute angles. So I'm getting 41.4 for this. So first answer is, if I start from 0, the first answer itself is 41.4. So this is our first answer. Second answer is starting from 0 and reaching to this line will be 360 minus 41.4. Second one comes out 318.6. So we got a solution in this one. First, second, because they are between 0 and 360, that's fine. Next, this will give us theta is equal to cos inverse minus half, right? And this time it is negative. Negative means the quadrants will be the other two quadrants. So this quadrant and this quadrant, in these two quadrants cos is negative, and this acute angle will be cos inverse positive half, which is pi by 3 or 60 degrees. So the first answer, if I want to start from 0 again, first answer will be this, which will be 180 minus 60. Which is equal to 120 degrees. Third answer is 120 degrees. And the fourth answer is 180 plus 60. From 180, this line, it is going further 60. So it will be 180 plus 60 comes out to be 240 degrees. So these are the four answers. No answer from the third one. Question 8. Express this particular expression in the form of this, where r is positive and alpha is between 0 and pi by 2. Give exact values. Okay. Because we want this particular format, so let's open this one. So r remains r, but cos 2x plus alpha, we'll use this identity to do that, cos a plus b, which is equal to cos a cos b minus sin a sin b. Okay, so that's what I'm going to do now. So r remains out and it becomes cos 2x cos alpha minus sin 2x sin alpha, and it is equal to 3 cos 2x minus square root 3 sin 2x. Okay. So if I multiply this r with each one of them and compare with this, what will that give me? Cos 2x is here, cos 2x is here. So the remaining part is 3. So that 3 will be equivalent to r cos alpha. Similarly, there is minus here, there is minus here. Square root 3 will be equal to r sine alpha, because cosine 2x is in both. R sine alpha. Now, to find alpha, we will divide this one, let's call it 2, let's call this 1. So we will divide 2 divided by 1, left hand side by left hand side, right hand side by right hand side. Sorry, I need to change this to square root 3 and this will be complete 3. And r sine alpha over r cos alpha. So r and r cancel. Sine over cos is tan alpha is square root 3 over 3. So alpha becomes tan inverse square root 3 over 3, which is pi over 6, not 3. Pi over 6. And that's what they said. Alpha is between 0 and pi by 2. Pi by 6 is the answer. Now, to find r, there is a shortcut, but I will explain the whole process to you. Then you'll be able to understand that better. So what will I do? I will do what? Equation number 1, which is this one, square plus equation number 2 square. Let's do this. So if I square this side, 3 square, plus add the square of this one, which is square root 3 square, should be equal to, the equivalent square of this will be r square cos square alpha, right? And the square of the right side will be r square sine square alpha. This is 9. This will be complete 3 because square root and square cancel, equal to r square, if I take common, cos square alpha plus sine square alpha. According to the identity, this is equal to 1, so we can ignore this. So r becomes square root 12. Because r is greater than 0, that means negative 1 we will not take, only the positive square root 12 will take, and r is there. So basically, if you want to do it directly, just square the coefficients and add them and then find their square root. That is the value of r. This is how we do it. Now, second part, it says, hence, find the exact value of this. And if you look at this, it is exactly matching with 3 cos 2x minus square root 3 sine 2x, square root 3 sine 2x, but square of this. So what will I do? I will just, whatever I've got, the format was this one, right? So in place of this, I will write here from 0 to 1 over 12 pi 3 divided by, now this has changed to r 2x plus alpha. R is square root 12. And then cos 2x plus alpha was pi by 6. And this whole thing is squared. Can you see? It is a square of the whole and dx. This is what we have to find the exact value of. Okay. Now, let's try to simplify this one first. So it becomes from 0 to 1 pi over 12, 1 over 12 pi 3. Now if I square the square root 12, it will become complete 12. Then cos will also be squared, and 2x, the angle will remain whatever it is. So squared. In this case, I can cancel this now and put this in front, 1 over 4. So 1 over 4 comes out, the limit remains what it is, and 1 over cos square will be secant square. 2x plus pi over 6 dx. I hope you understand the whole process. The constant has been taken out and secant square is 1 over cos square. The integration of secant square is tan. So it will become 1 over 4 tan 2x plus pi over 6 divided by the differentiation, not integration, differentiation of the angle, which is just 2. Because differentiation of 2x is 2 and differentiation of pi over 6 will be 0. And we will write plus c. Okay, and now we have to evaluate this, which we can do it easily. So 2 multiplies with 4, so it becomes 1 over 8. And it was from where? 0 to 1 over 12 pi. So I'll substitute 1 over 12 pi first. So tan 2 1 over 12 pi plus pi by 6 plus c minus tan 2 times 0 plus pi by 6 minus c. Usually people don't write c. I have a habit, so I'm just skipping it because ultimately they get cancelled out, so there was no need to write c, but I do that. Okay, 1 over 8, this cancels out, so pi by 6 divided by pi by 6 is pi by 3. Tan pi by 3 is square root 3 minus tan, and this is 0, pi by 6 will be 1 square root 3 over 3 we can write, and that's it. So now 3 square root 3 minus square root 3 will be 2 square root 3. So 1 over 8 times 2 square root 3 over 3. Okay, so this and this can cancel now. So we get square root 3 over 12. This will be the value of the given definite integral. Question 9. A container in the shape of a cuboid has a square base of side x. Okay, so this is a container and it is of cuboid shape and its base is x by x, right? Side x, and the height of 10 minus x, this is 10 minus x. Okay, it is given that x varies with time t, where t is positive obviously. The container decreases in volume at a rate which is inversely proportional to t. So the volume decreases which is inversely proportional to t, or we can write dv over dt is equal to k over t. When t is half, no, t is 1 over 10, x is half, and the rate of decrease of x, that means rate of decrease of x has to be written. So let's do it somewhere here. We know that the volume is x multiplied by 10 minus x. So x square 10 minus x, this is the volume. Or I can write 10x square minus x cube. Now if volume changes with respect to x, so we'll differentiate with respect to x, equal to, it will be how much, 20x minus 3x square. However, time is another parameter here and that we don't have here. So what will we do? We'll divide this by dt and divide this by dt. That makes it with reference to time also. So dv over dt over dx over dt is this. And it is matching here. So good. Now, when t is 1 over 10, so t is not there, but we know that dv over dt is k over t, right? So I can write this one as k over t, and because denominator of numerator is also denominator, so I can multiply it with dx over dt is equal to 20x minus 3x square. Basically here they are helping us to find k. So k is unknown, k remains k, but time they said is how much? 1 over 10. So again, new denominator of a denominator becomes numerator. So 1 over 10, I will write 10 as numerator, 1 over 10 in place of this t. Dx over dt, we have to prove rate of decrease of x is 20 over 7. So they have given it dx over dt, they have given minus 20 decrease, means it's minus, okay? So minus 20 over 37. So again, denominator of denominator will become numerator 37 here, okay? Equal to 20x, x is half, so 20 times half minus 3 times half square. So everything is there, k is the only one unknown, and which we'll find out. So it becomes what? 10 and minus 20 can cancel, we get minus 2. So here we get minus 37 over 2k overall. This is 10 minus 3/4. 3/4, so 40 minus 3, 37 over 4. So now 37 on both sides, multiplying, so they can cancel out here. So k is, this gives us k is equal to, 2 goes there with negative, so minus half, k is minus half. So that was our equation, right? This one. Let's substitute to get what they are asking here. Okay, so dv over dt, dv over dt is k over t, right? So in place of this dv over dt, I will write k over t, and k is minus half. So I will write minus half t. No, t will be here, yeah? If I put k equal to minus half, it will become minus 1 over 2t, that is dv over dt. Over dx over dt, equal to 20x minus 3x square. So let's do what? Let's bring this one to the other side as a denominator and bring dx over dt to the other side with numerator, because cross multiplication allows that, and this is what we want here, right? So minus 1 over 2t multiplied by 20x minus 3x square equal to dx over dt. And exactly this is what they wanted us to show. So we got it. Next, solve the differential equation. Okay, solve the differential equation, this one. Obtaining the expression for t in terms of x. So t should be isolated. So what will we do? This is dt and this is t. So we'll keep them together by cross multiplication again. So dt goes there over 2t. And these x's will come with dx. 20x minus 3x square dx. And this is what we are going to integrate both sides to get the differential equation, solving it and get an expression. So 1 over t dt is natural log t, right? And minus half remains minus half. Let's keep it in front. So minus 1 over 2 stays out, and dt over t gives us natural log of t equal to the differentiation, so the integration of 20x will be 20x square over 2 minus 3x cube over 3 plus c. Right? I didn't write c here because both of them will give a constant. All right. So now, can we get c here from here? So we can use this one. When t is 1 over 10, x is half. This is what we can use. So minus half when t is 1 over 10, x is half. So this cancels, so 10 half square. This cancels, minus half cube plus c. So let's see if we get something out of this. So there will be 10 over 4 minus, or rather let's make this one as exponent. So we will write here natural log 1 over 10 to the power minus half equal to 10 over 4, which is 5 over 2 minus 1 over 8 plus c. Okay, so 10 to the power minus half will be square root 10. So natural log, let's go it here. Do we want exact form? Okay, let's do it. Natural log of square root 10. That's what it will be. Yeah, because minus half will bring this 10 as a numerator to make it positive, and then 10 to the power half is square root 10 equal to, it will be how much, times 4 times 4. So 20 minus 1, 19 over 8 plus c. So let's bring 19 over 8 also to the other side. 19 over 8, and that is equal to c. All right, so let's put this here and we get it here. So this was our equation, right? So natural log t to the power minus half. Yeah, that's what it will become, by equal to 10x square minus x cube. And now we know the c we can write here, plus natural log square root 10 and minus 19 over 8. Okay, so to get this c, this t, because they said obtain t in terms of x, not ln t, so I'll have to take this natural log there. So it will be natural log 1 over t square root t rather. Why? Because this minus has to become positive, and for that it has to become denominator. So minus natural log square root 10, this came here, equal to 10x square minus x cube minus 19 over 8. And now these natural logs will become this divided by this, which is divide means it will multiply with here. So 1 over square root 10t equal to 10x square minus x cube minus 19 over 8. Now we need to get rid of this natural log, so it becomes 1 over square root 10t equal to e to the power 10x square minus x cube minus 19 over 8. And to get this t, we'll have to square both sides, so square and square. What do we get? This will become 10t, 1 over 10t complete 10t equal to e to the power 20x square minus 2x cube minus 38 over 8, or 19 over 4. Finally, if I want to isolate t will come here, and this whole thing will come with 10. So what will I get? T equal to 1 over 10 times e to the power 20x square minus 2x cube minus 19 over 4. I hope I've not made a casual mistake or calculation mistake here. If I've done so, please give me that information in comments, but not repeatedly. If somebody has given already, then do not repeat it, please. Question 10. The equations of two straight lines are vector equations. Basically, they are this. Okay. So this m and n in original question were alpha, lambda and mu's, but I'm using m and n here. Okay, a is here and a is here, so this is there where a is a constant. Given that the acute angle between the directions of these lines is 1 over 4 pi, find the possible value of a. So this is the vector part and this is the vector part. The angle between them is 1 over 4 pi. Find the value of a. So the dot product of two vectors is equal to magnitude of a multiplied by magnitude of b cos an angle between them, right? So let's do this one first. So a will be 3i plus 4j plus ak dot minus I plus 2j plus 2k will be equal to magnitude of a will be magnitude of this 3 square plus 4 square plus a square and multiplied by square root minus 1 square. Let's write 1 square only because minus and positive squared doesn't make any difference. 2 square plus minus 2 square or plus again plus 2 square cos and the angle is 1 over 4 pi. Okay. So now if you want to find the dot product of them, the I will multiply with I, so minus coefficients only, okay, minus 3, and because I dot I is 1, so no need to look at it. So 4 times 2 is 8, a times 2 is 2a equal to, okay, this is 9, this is 16, so square root 25 plus a square multiplied by 1 plus 4 plus 4 is 9, square root 9 is 3, and cos 1 over 4 pi is 1 over square root 2. Okay, now this will be 5 plus 2a equal to 3 over square root 2 square root 25 plus a square. Okay, now I need to get rid of this square root, so I will square the both sides. And when we say both sides again, whole of it will be squared. So the square of this will be 25 plus 4a square. Basically I'm writing the identity a square plus b square plus 2ab. So 2 times 5 times 2 will be 20a. And if I square this one, it will become 9 over 2. 3 square is 9, square root 2 square is 2, and 25 plus a square. Okay, so let's multiply this 2 here and 9 with this one. So 2 multiplied with 25 gives me 50 plus 8a square plus 40a equal to 225 plus 9 a square. Okay, let's bring everything to the right side. So 0 left here, and this 8a square will come here with 9a square. So 9a square minus 8a square is just a square. Then 40a will become negative 40a. And then 50. 225 minus 50 will be 175. This becomes a quadratic equation. So we will just solve this and get our answer. I'll use the splitting the middle term method. So you can use quadratic formula if you're not sure about this. So the 175, its factors are 35 and 5. So that makes it 40. So minus 35a minus 5a plus 175, 0 equal to a common, a minus 35 minus 5, a minus 35. So a minus 35 is in both, and a minus 5 is common. So this gives me two answers. A minus 35, either this is equal to 0 or a minus 5 equal to 0. So a equal to 35 or a equal to 5. These are the two possible values of a. Okay, find the possible values of a. So 35 and 5. Given instead that the lines intersect, okay, find the value of a and the position vector of point of intersection. That means there is a common point between the two lines. Okay, earlier they were making an angle but at different planes. They were not intersecting. But in this case, they are intersecting. They have a common point. So I will do it. I will just copy them first. So these are. So here they are. So if they have a common point, they are intersecting at a point. That point will have same coordinates, right? So let's call that. Let's convert these to parametric form in both cases. So in this case, x will be 1 plus 3m. Yeah, y will be 1 plus 4m, and z will be 2a plus am, or I can write 2 plus m a, whichever will be applicable. Okay, now second, here it will be 3 minus n. So x will be 3 minus n. Then y will be minus 1, this one minus 1 plus 2n. Z, okay, 4 plus 2n. And actually it is not 3 minus n, it will be minus 3 minus n. Can you see here there is a minus which I ignored, so it will be minus 3 minus n. Since they are intersecting, so this x will be equal to this. So 1 plus 3m should be equal to minus 3 minus n. So let me bring n to the left side so that it becomes positive, and rest everything here. So minus 3, which is already here, minus 3m and minus 1. So n comes out to be minus 4, minus 4 minus 3m. Okay, now we'll use it in this second one. So 1 plus 4m, 1 plus 4m should be equal to minus 1 plus 2n, minus 1 plus 2n, and n is this, so 2 minus 4 minus 3m. So let's keep 4m here and bring this 1 to the other side, so it will become, besides this minus 1 there will be another minus 1, and then 2 times minus 4 is minus 8, 2 times minus 3m will be minus 6m. So let's bring this minus 6m to the other side, so 4m plus 6m equal to minus 10, and 10m, sorry for this, equal to minus 10. So obviously m comes out to be minus 1. Okay, now we need to find n, and we can get n from here. What is it? So minus 1 is m, n equal to minus 4 minus 3 times minus 1, which is plus 3, so minus 1 again. So n is also minus 1. Okay. I hope I've not made any silly mistake here. Okay, so now z will give us the value of a now. So 2 plus m, 2 plus minus 1, which is 2 minus 1, a will be equal to 4 plus 2n, 4 plus 2 times minus 1. So 1, so a is equal to 4 minus 2, 2. This is what we're getting. It was actually lambda and mu. M and n were lambda and mu in main question. I've taken them as m and n. Question number 11. Use the substitution 2x equal to tan theta. That's what they're saying. So let me write it, tan theta. To find the exact value of this one, give your answer in the form of a plus b pi blah blah blah. Okay, so first let's see how we can change here. So 2x is equal to tan theta. So if I square both sides, if I square this one and square this also, it will give me 4x square equal to tan square theta. Okay, so that means this 4x square can be replaced now. So I'm not writing limits first, I will just write them later. So it will be 1 plus tan square theta and then whole square. Now we need dx to be replaced with d theta. How? If I differentiate this dx over d theta, differentiate this with respect to theta, will be what? If I this 2 I write on the other side, so it will become what? X equal to half tan theta, so its differentiation will be half secant square theta. Okay, because I want this, so d theta if goes and multiplies with this other side, dx becomes half secant square theta d theta, and that's what I will write here, half secant square theta d theta. Now this 2 can cancel with the 12, so let's keep 6 out and we'll be left with just secant square on the numerator over 1 plus tan square theta is also secant square theta, so it will become secant to the power 4 theta, isn't it? Because of this square, secant square theta will also be squared, so we can cancel this now with 2 of them. So what do we get? 6 1 d theta over secant square theta. 1 over secant square theta is actually cos theta, cos square theta, so it will become 6 cos square theta d theta, and now this will be easier to be integrated. How? We'll have to use this. Cos 2 theta is equal to 2 cos square theta minus 1. This is an identity, and if I bring this one here, it becomes 1 plus cos 2 theta equal to 2 cos square theta, right? And if I get this rid of this 2, it will become cos square theta is 1 plus cos 2 theta over 2, and that's what I'm going to write here. 6 remains outside, 1 plus cos 2 theta over 2, right? Whole over 2, so let me write them separate so that I can integrate them separately. Alright, 6 times half is 3, and if I integrate that 3, I'll get 3 theta, isn't it? Plus, again this 2 also cancel with 6, so 3, and what is the integration of cos 2 theta? Sine 2 theta over 2. This is the integration of cos 2 theta. Then we'll have c here and some limits. Now limits are to be found out, so let's do it here. We wrote that 2x is equal to tan theta here, right? I want to change the limits. So if it is 0, if x is 0, so 2 times 0 is equal to tan theta, right? So this is 0, so theta becomes tan inverse 0, which is 0. So the lower limit of this is 0. What about the upper limit? It was 1 over 2 in this case, right? So x becomes 1 over 2 equal to tan theta. So 2 and 2 cancelled, tan inverse 1, and tan inverse 1 is pi over 4, or 1 over 4 pi. So we can write 1 over 4 pi here. Now I have to substitute this first, so 3 times 1 over 4 pi plus 3 over 2 sine 2 times 1 over 4 pi, yes, plus c minus 3 times 0, 0, plus sine 2 times 0 is 0, sine 0 is 0, so this whole thing is also 0, plus c. C will cancel with this c because of this minus. So what is left here? 3 over 4 pi, this also cancel. So sine half pi is 1, so plus 3 over 2. And we wanted a plus b pi, so a comes out to be 3 over 2, b is 3 over 4. That's the solution of this particular question, number 11. This concludes our solution video. If you liked it, please make sure you share with your friends and give it a thumbs up, and subscribe to Math United. Thank you very much.